Hello, so today we're going to work through the Prep for Calc Exam 1 review for fall 2023. So, starting off with question number 1, we are given the functions f, g, and h, and we need to answer each of the following. So, real quick on the right side, we have h, which is the graph. We have f, which is the table, and we have g, which is the equation. Sorry, just make sure the pen works. First, we need to find what f of 5 is. So, right here, when I look at this, 5 is the thing inside the parentheses. That is my input. So I'm going to go to the table. My input is 5. So x's are my input. So my input is 5. So my output is 7. Next is find h of negative 1. So negative 1 is my input. So it means on the x-axis, I'm going to look at find negative 1. I'm going to go straight up until I hit the graph. And where is that at? It's at 4. On the y-axis. Okay. Next, this one's a little trickier. Find g of 3a. So where I have, for g of 3a, where I had an x, I now have a 3a. So everywhere in this equation where I have an x, I'm now going to have a 3a. 3a squared. I'll kind of work it out over on this side over here. So to try to simplify some things a little bit more, we're still going to have 1. Nothing changes there. 3 times 3a is going to be 9a. Minus 2, and then I'm going to go ahead and square the inside. So 3a times 3a is going to be 3 times 3 is 9. A times a is a squared. So our final answer is going to be 1 minus 9a minus 18a squared. So I'll rewrite that over here. And again, I got that because this is g of x, but I'm told to find g of 3a, so that 3a is replacing the x, so in the equation, I replace all my x's with 3a. That's 18a squared. Okay, for this next one, solve h of x equals 0. So before we had h of negative 1, where negative 1 is the input, now we don't know the input, but because it's equal to 0, it tells us the output. So I'm going to do a different color on this one. So that means that we're looking for when our y is equal to 0. So that's this y-axis. I see one right here. If I go this way, I see one over here. So I have two spots where the y equals 0. What are they? They're x equals minus 3 and x equals 1. Finally, again, solve g of x equals 1. So now the 1's on the outside, so that means I'm going to take this equation, g of x, and I'm going to set it equal to 1. So I'll do it up here. So I'll say 1 equals 1 minus 3x minus 2x squared. So I'll subtract the 1 over. So I'll get 0 equals negative 3x minus 2x squared. I have an x on both of these, so I'll factor 1 out. So I'll have 0 equals x times minus 3 minus 2x. And because I have two things that multiply together to equal 0, that means either this one equals 0 or this one does. 2x, sorry, I'll put the 0 on the right side. And I can now solve this for x, so minus 2x equals positive 3 when I add the 3 over. And x equals negative 3 halves. So my answers are when x equals 0 or x equals minus 3 halves. And previously, I'll switch the word from and to or, because you can't have both of those be true at once. X cannot be two things simultaneously. So, question number 2. If p of x equals negative 2x squared plus bx plus 5, and p of negative 3 equals 7, what is the exact value of b? So again, with this notation, we saw it earlier with the f of 5, h of negative 1, g of 3. The thing on the inside is our input. That's what we're replacing our x's with, and that's our kind of our output there, which is what we're setting it equal to. So, again, we normally have a p of x. Well, now we have p of minus 3. So where our x's were, those are going to become minus 3's. So, negative 2 times negative 3 squared plus b, we don't know what that is. We'll try to solve for that, times negative 3 plus 5. And what is that going to equal? That's going to equal whatever we get out of it, which according to this is equal to 7. So equals 7. So So now we can try and solve for this. So minus 3 squared is going to be positive 9 plus, and I'll say this is negative, instead of plus, I'll say this minus sign is going to become minus 3b. I just kind of rearranged it. You can do that with things that are being multiplied. Plus 5 equals 7, which, moving down here, is going to be negative 18 minus 3b plus 5 equals 7. So now I'm going to try to combine like terms, so I'll combine these two together. So I'll get minus 3b, or sorry, minus 13 minus 3b, I got ahead of myself there, equals 7. And now I'm going to move this minus 13 to the other side to get the b's by itself. So I'll get minus 3b, and I'll add 13 to both sides, so I'll get equals 20. And lastly, I'll divide each side by negative 3. So I get b equals negative, because there's a negative 3 over, negative 20 over 3. Just dividing by negative 3 makes that negative. So what is the exact value of b? That is negative 20 over 3. For number 3, it gives us f of x is equal to 3 times x minus 1 squared. Simplify, find each of the following and simplify completely. I'm going to let me erase some of this stuff over on the side real quick to give myself a little more space to work. And I'm going to switch colors just for the fun of it. Ooh, it's blue now. Okay. So, f of negative 2. Well, we're at an x and I have a negative 2. So over here, where I had x's, I'm now going to have negative 2. Negative 2 minus 1 is negative 3. Negative 3 times negative 3 is 9. So negative 3 squared is 9. So 3 times 9 is 27. Part B, it's f of negative 2 plus h. Again, this one is something that I don't get a lot of people confused. But we originally had f of x, now we have f of negative 2h. So where in our f of x we had x, we're going to put that whole thing in there for x. So that's going to be 3 negative 2 plus h minus 1 squared, which we can go and combine the negative 2 and the negative 1 inside. Negative 3 plus h squared. So I go on the left side over here to figure out what that thing squared is. So negative 3 plus h squared is the same thing as negative 3 plus h times negative 3 plus h. And so what I'll do is I'll FOIL it. That is first, outer, inner, and then this one is the last. And most of you guys have probably heard of it, but if you don't, there you go. You're welcome. You can, I don't know, thank me later. So the first, minus 3 times minus 3 is positive 9. Outer, minus 3 times h is going to be minus 3h. Inner, h times minus 3 is going to be another minus 3h. And last, h times h is going to be h squared. So we get 9 minus 6h plus h squared. So I'll go and I'll put that. Remember, we still have this 3 outside. We didn't do anything with that yet. So it's 3, and that whole squared thing becomes 9 minus 6h plus h squared. And we can go and distribute the 3. So we get 27 minus 18h plus 3h squared. Okay. Now, next up, what we can do is f of negative 2 plus h minus f of negative 2 over h, where h is not equal to 0. So I'll take the second one we did, this big one, put that on top. Sorry, I was just looking back and trying to make sure I wrote everything down correctly. Minus f of negative 2, which is 27, all over h. Well, the first thing I can do is I can combine my like terms. 27 minus 27, those cancel. So we get minus 18h plus 3h squared over h. Each term on top has an h in it, so I'll factor one out. So I have h times minus 18 plus 3h over h. And because h isn't 0, we can go and divide. So that gives us minus 18 plus 3h as our final answer. Okay, the last one of this page. For the function f of x equals the square root of x minus a, where a is a real number, find each of the following. A is find the set of all input values of this function. So the first thing I'm going to do is I'm going to draw a graph of kind of what this looks like. You guys can't do that. That's totally fine. Like, that's not expected. But there's a few different ways we can do it. But knowing the graph is going to be really, really helpful for us. So I'll put this apart at A. A square root graph looks something like that. Well, the reason why this stops at A is because if I put something less than A, say like, if I put something over here, well, if this is less than A, then x minus A is going to be negative. Square root of a negative number is imaginary. We don't do that. The other thing that we should notice is that it doesn't go below this axis because you can't get a negative out of a square root. You always get positive numbers out of a square root. So if it's just square root of x minus A, we're not going to get any negatives out. So we're not going to have any values below. So for our set of input values for this function, it's going to be bracket to include. I always think of the bracket includes because it's like almost like a house. Like you want to put that number inside of it. You want to protect it. Comma, infinity, because it's just going to keep going right forever. And then, round parentheses, because, it's almost like trying to avoid it because it absolutely does not want to include it. And then for output values, it's going to be 0 to infinity. So to kind of explain these answers a little bit more, if I plug in A into this, you'd get square root of A minus A, which is square root of 0, which is just 0. But if I put something less than A, you get a negative inside. That doesn't work. Anything bigger than A, you can take a square root of a positive number. You'll get something out. For the set of output values, those are the values we get out of it. Well, I just showed that, look, we can get 0. That works, so we include 0. And then anything bigger, right, you can figure out like what you need to plug in to equal it, right? So yeah, you can get you'll reach every positive number, but we won't get any of the negatives. So I guess there's that.
All right, let's start with number 5. Number 5 asks, what are the domain and range for the function f shown on the graph? Use interval notation. So domain has to do with x values, so we're going to look at what the x values are on this graph. So the farthest left, or the smallest value of x that we see, is -3. And the largest or farthest right value of x that we see is 7. Now there's something unique going on here. Let me first write down -3 and 7. That at this point, we see that there's a hole at that point, -3, 8. And here, there's a solid dot. So because of this, we're going to use a round parentheses for the left and a bracket on the right. Because of that hole, the domain doesn't actually include the value of -3. Okay. Next, for the range, we're going to look at the y values. So the lowest, or the most smallest y value is -12. We see it down here. And the highest is actually also at 18, where that other point was for the domain. And here, there are no holes to consider, so we will just say with square brackets that the range goes from -12 to 18. For number 6, we're finding the domain for each function, again, using interval notation. So the two things that we need to look at when we're considering domain is the fact that we can't divide by 0, that we can't take the square root of a negative number. Okay, so let's go one fraction at a time. So if we look here, we see that in the denominator, we have x plus 2.9. And like I said, we can't divide by 0, so this can't equal 0. So that means that x can't equal negative 2.9. Okay? Now let's move on to the next fraction, 1 over x plus 7. So again, we can't divide by 0, so we need to say that x plus 7 can't equal 0. So x can't equal negative 7. Lastly, let's look at this square root. Can't take the square root of a negative number, so x plus 6.4 needs to be greater than or equal to 0. Okay? So this means that x needs to be greater than or equal to negative 6.4. Now we have 3 statements about the values of x. Okay? So first, we know that x can't be equal to negative 2.9, x can't equal negative 7, and x needs to be greater than negative 6.4. So first, we can say, okay, x is greater than or equal to negative 6.4. Now, what about this x can't equal negative 7? But since negative 7 is less than negative 6.4, we just won't consider it. So now we'll take this interval up to negative 2.9 where there's a break because we can't equal that value. And then we'll continue this all the way to positive infinity. It's 2.9 there. Okay, that's the domain for part A. Now for part B, we need to look at this fraction. Okay, so we have x plus 2 over x squared minus 3x minus 10. All right, so let's look at what the bottom of this fraction factors into. X squared minus 3x minus 10. This equals x minus 5 times x plus 2. Now, even though those x plus 2's will cancel on the top and the bottom, we still need to consider that for the domain. Again, we can't divide by 0. So x minus 5 can't equal 0, and x plus 2 can't equal 0. So x can't equal negative 2 or 5. So let me write this domain in interval notation now. So the domain equals can go from negative infinity to negative 2 union negative 2 to 5 union 5 to infinity.
Okay, so this next part is going to be a little bit similar. So we are looking for the domain of each of these functions and matching it with the choices given on the right. And so for this first one, for part A, we know that if there's something in the denominator, then it cannot equal 0, right? So we're going to set both of those equations up. So we have x cannot equal 0 for the first fraction. And then we'll have x minus 1 cannot equal 0 for this second fraction. And so if we solve this one, that'll give us x cannot equal 1. So we'll have x cannot equal 0 and x cannot equal 1. So if we set that up in interval notation, that's going to look like we can start at negative infinity and we can go all the way until we hit 0, and then we have to stop because x cannot equal that. And then we can pick back up and start back at 0 and go all the way to 1. We have to stop there. And then pick that back up, start at 1, and then continue all the way to infinity. So the choice that mirrors this most likely looks like I. So that is going to be our answer for part A. Now for part B, you'll see that we have a square root in the denominator, right? So if we look at the square root, we know that if we have a square root, we say that whatever's in the square root, in this case 1 minus x, has to be greater than or equal to 0. But the square root is in the denominator, and we've said that when it's in the denominator, it cannot equal 0, right? So this inequality is going to be rewritten as 1 minus x has to be greater than 0. It cannot equal 0. And so then what we can do is we can add this x to both sides, and then we'll get x is less than 1. So x has to be less than 1. So if we model that domain, that's going to look like we start at negative infinity, right, because it has to be less than, and then we go all the way until we hit 1. And so the letter that most mirrors this is B. So we can go ahead and select that, put that in here. Okay, now if we go on to part C, we have two separate ones we have to set up, right? So if we go ahead and take a look at the numerator, that's going to be in a square root, so it's going to be x plus 1 has to be greater than or equal to 0. And so if we solve this inequality, that's going to be x has to be greater than or equal to negative 1. And then we can do our denominator again, so that's going to be, come over here, that's going to be 2x minus 2 cannot equal 0. Or if we solve for that, we get x cannot equal 1. And so how are we going to write this? Well, that square root says it has to be greater than negative 1. So we're going to start at negative 1. And then we're going to go until we reach that point where it cannot equal 1. And then we're going to union that. And then we're going to pick back up at 1 and go to infinity. And so the choice that most resembles this is M right here. And that's problem 7. Okay, so for problem 8, we got a word problem here. It says the monthly charge for water depends on your usage. For a customer using no more than 20,000 gallons of water in a month, the monthly charge in dollars is given by the function c of x is equal to 0.004x plus 15 when x gallons of water are used. What are the domain and range for this function? Okay, so first, we should start by defining our variables that were given. So right now we have our c of x, and that is the monthly charge. Okay, and for our x, it says x is what? X is gallons of water used. So we'll just say that's gallons of water. Okay, and so if we pick out some of the important pieces of this word problem here, it says for a customer using no more than 20,000 gallons of water in a month. So this means that this equation only applies when gallons of water is less than 20,000, right? So we know that our x is going to have to be less than or equal to 20,000, right? But if we think about this in practical terms, we also know that we can't have negative gallons of water being used. So we know that the least amount of gallons of water that anyone can use is 0. So we have our domain set up right here. And so now to find our range, all we can do is, because this is a linear function, you know, it's going to kind of look like this. And so the leftmost point is going to be its lowest point, and the rightmost point is going to be its highest point with its biggest y value. So we can just plug these points in to find our range. So if we do c of 0, that's going to be 0.004 times 0 plus 15, which is going to give us 15. And then if we do c of 20,000, that's going to equal 0.004 times 20,000 plus 15. Oh, erase that. Which gives us 95. And so if we write this in interval notation, we are going to start at 0 and go to 20,000. And then for our range, we start at 15 and go to 95 included. Okay, so for number 9, to find a function that has a domain that is given to us. So if we look at the leftmost part of the domain right here, we have a -6, and we see that x has to be greater than or equal to -6. So if we write this out, that's going to be x has to be greater than or equal to -6. Okay, so then if we add this 6 over, plus 6, we get that x plus 6 has to be greater than or equal to 0, which is modeled after a square root, finding the domain of a square root. So we know that this function, and if I write it on the left side of this number 9, we know that this function is going to have a square root of x plus 6. Okay, so if we continue on our domain, we see that it stops at -1, and it cannot equal 1 because of the open parentheses. So then we say that x cannot equal -1. So if we add this 1 over, we get that x plus 1 cannot equal 0, which is modeled after the domain of it being in the denominator, right? So we know that we're going to have the square root of x plus 6, and it's going to be over an x plus 1. And so then, if we keep looking at our domain, we pick back up and we see it can't equal 5 either. So we have an x, it cannot equal 5. So then if we subtract 5 on both sides, we get x minus 5 cannot equal 0, which again models something that's in the denominator, right? So what we can do is we can just multiply this over here, because we know that if one of these sets of parentheses equals 0, then the whole function is going to be undefined. So when all is said and done, we can write f of x is equal to this whole thing right here. Okay, so for problem 10, it says what's the domain of g of x where a is greater than 0 and b is greater than a. Okay, so this a greater than 0 and b is greater than a. So it defines that because if a were less than 0, then we know that the x domain would have to start at -infinity. And it defines that b is greater than a because if b were less than a, then we wouldn't even need to worry about the domain of that because it wouldn't even be included in that domain. And if you're still a little bit tripped up on this, I recommend kind of plugging in numbers to see if this makes sense. So like, what happens to the domain if a is less than 0, if a is like -2? And what happens to the domain if like a is equal to 1, but b is equal to -3? Just try and kind of experiment with it because this is why they define those. But going back to our problem, it says where a is greater than 0, b is greater than a. So if we start with this top square root right here, we know that with the square root, we have x minus a has to be greater than or equal to 0. So then we know that x has to be greater than or equal to a. And then for the denominator, we'll have x minus b cannot equal 0, or x cannot equal b. And so then if we write that in interval notation, we start at a, that is our starting point, and then we go until we hit b, and it cannot include b. So then we give a parentheses right there, and then a union, and then we pick back up at b and go to infinity. So that is the domain of our function. Okay, so for this next one, on number 11, we have what is the domain of g of x of that same function, but this time a is still greater than 0, but a is also greater than b. So if we think about this, and we start with the square root up here, we'll have x minus a has to be greater than or equal to 0, right? So then we'll have that same thing we had up at the top of number 10. We'll have x has to be greater than or equal to a. And so if we think about this, this means that a has to be our leftmost point. It has to be our smallest x value, right? So if b is smaller than a, then that means that we won't even have to do a setup for this because our domain can never hit that b point. So our domain is just going to look like starting at A and going to infinity. All right, so for number 12, we have an average rate of change problem. And so we know that the equation for average rate of change is y2 minus y1 over x2 minus x1. So if we're looking for the average rate of change on the interval 2 to 4, we know that our x1 is going to equal 2 millimeters, and our x2 is going to equal 4 millimeters. So then that means our y2, write this on the right, sorry, that's going to be f of 4, which gives 2 over 4 squared, which equals 2 over 16, or 1/8, and that's going to be in newtons. Okay, so then if we do our y1, that's going to be f of 2, which is 2 over 2 squared, which is equal to 2 over 4, which is equal to 1/2 newtons. So then, if we plug all of these into our rate of change equation, we'll get our y2, which is 1/8 newtons, minus 1/2 newtons, over 4 millimeters minus 2 millimeters. That'll give us a negative 3 over 16, and that is newtons per millimeter. Okay, so we have some more average rate of change practice going on here. So if we look at part A, we are calculating the y values at these specified x points. So what that's going to look like is, for this first one, for f of 1, that's going to equal 5/2 times 1 plus 3 squared, which is equal to 40. So I'll just put that down here. All right, and so then for f of 2, it's going to equal 5/2 times 2 plus 3 squared, which equals 125 over 2, or if you want to put it in decimal form, that's going to be 62.5. So we'll put that down here. All right, so then f of 1.5, it's going to be the same thing. So if you do that, that's going to equal 50.625. 50.625. And then f of 1.1 is going to equal 42.025. 42.025. And then f of 1.01 is equal to 40.20025. So put that down here. 20025. All right. So now we can use these y values to calculate our average rate of change. So for part A again, we can set up our average rate of change equation from 1 to 2. So that's going to be, let's see, that's going to be f of 2 minus f of 1 over 2 minus 1, right? So then that's going to be our 62.5 minus 40 over 1, which is going to give us 22.5 for first one. For our second one, so that's going to be f of 1.5 minus f of 1 over 1.5 minus 1, right? So if we look at our 1.5 y value, that's going to be 50.625 minus our f of 1, which is the same as just 40, over 1.5 minus 1. We put that in our calculators, and we should get 21.25. Okay, now if we do from 1 to 1.1, that's going to be our f of 1.1, which is 42.025, minus our f of 1, which is still 40, all over 1.1 minus 1, which is going to give us 20.25. 0.25. And now for our last one, this even smaller interval from 1 to 1.01, we look at our f of 1.01, and we said it was 40.2005 minus 40 over 1.01 minus 1, which is going to equal 20.025. Alright, so for part E, it asks us the length of the interval from x equals 1 to x equals 1 plus h, where h is greater than 0 gets shorter. Does the average rate of change appear to approach a specific number? If so, what? Alright, so if we look at all these average rate of changes we calculated, we can see that, well, the increment gets shorter for the x values, right? And our y values kind of approaches 20 a bit, right? So like by the time we get to this last point, it's 20.025, which is about 20. So I would say that the average rate of change approaches 20 as h is greater than 0 gets shorter. All right.